Test 1, 2. All right. All right. First and last stream of the week. So let me see what I gotta do. I do need to make an architecture diagram. Yeah, the KEDA people asked me to do that, and I'm trying to figure out where the hell that issue is. It's like on the third page. I can never remember. It's like scaling. Oh, it's first class support, I think. Yeah, there it is. So they asked me somewhere. As requested, I will make an architecture diagram. That's what I said. And I don't remember where they asked. I know that they asked somewhere. So I'm gonna try to do that. Excalibra. I've been meaning to try out Excalibra. Excalibra.com. Okay. So KEDA and KEDA-HTTP. So KEDA is here. How do I put text in here? There we go. Oh, that's a font and a half. How do we just do a normal font? Normal code. That works. So that's KEDA. Let's actually make this the Kubernetes cluster. So we're just gonna do one of these. Kubernetes is here. What's going on with this text box? There we go. So this is Kubernetes, and then we're gonna have like the internet. And we'll put the internet here. It's a series of tubes after all. So that's that. Oh, nice. It follows it too. Okay. So we've got HTTP clients. Is that code? Okay. Kubernetes. And then we're going to have our deployment here. And there's going to be a service. Let's make this a box. I don't know about this ellipsis idea here. There's a deployment here, and there's going to be a service here. All right, and then the service is going to just forward on to the deployment as expected. All right, you go there, and there's going to be an ingress controller. I'm gonna make that box a little bigger here. Bah. All right, so the ingress controller is gonna forward onto here. And then there's going to be ingress objects here. Those are going to get consumed by the ingress controller. Okay. We're gonna, I wonder if you can put text inside of a box. That would make things way easier. Actions, no. What? No, that's not a thing either. All right, whatever. That's fine. So ingress controller forwards to services. To the app service, and I'm going to call this the app deployment. Okay. App service sounds like that's an Azure product, so I don't know. I guess I'm biased towards that being an Azure product, I suppose. All right, so we've got that, and now we've got over here. So we've got KEDA down here. KEDA. And KEDA is going to read scaled objects. And it's also going to scale deployments based on what it reads in the scaled object. Okay. All right, so that's the basic idea. Well, the deployment, the KEDA, the scaled object, that's the basic idea of KEDA. And the service thing, so let's put this box around it to kind of indicate that this is the KEDA universe. Okay, and now there's the ingress, the service, all that good stuff. All right, and then there's going to be another thing off to the side, which I'm going to call the activator. Okay, and the activator is actually going to sit here. And the activator is also going to mess with the ingress. So that's a little tough to handle here. Let's put this all over here. So we've got service here. We've got ingress here. So the activator is going to have to forward to the service in some cases, and in other cases it's going to have to modify the ingress. So that's real bad. It's real messy. Let's put the activator in the middle. Oops. So let's put the ingress over here. We're gonna delete that. And we're gonna put the activator here in the middle. So the activator then will forward to the service when necessary. We'll also modify the ingress when necessary. So that will, yeah, the ingress will tell the ingress controller. How do I put two arrows on this bad boy? I guess I cannot do that. So we'll just do this. Blah. That's not going to be useful for me. Okay. Okay. All right, so the ingress controller reads the ingress. You will go here. KEDA reads the scaled object, so let's put it here. Hey, Rockaroo, what's up? Yeah, slam the undo button. You got it. This is the first time I've used Excalidraw. I actually don't even know how to save. Oh, okay, fine. Can I save this on the interwebs? Live collab. Load. Well, hope my browser doesn't crash. Oh, I can? How do I collab, save as, export? Oh, it saves the local storage. All right, that's cool. Good enough for me for now. All right. Let's move this down here a little bit just to see the clear separation. Okay, so we've got the KEDA world here. We've got the serving, I guess it's called like the serving tier, the net, I don't know, the HTTP tier of this thing. And then the final piece, the final piece is going to be, we've got this thingy called the controller. That's the one, that's the thing that I'm actually building. You clear your local storage. That sounds like a plan. Putting arrows in the correct direction. Yeah, you gotta have multi-way arrows sometimes. So we've got our operator. The operator is going to interact with this app CRD. And I should mark this as a CRD. All right. Got our little app CRD here. Okay. Now, two-way communication here. In reality, these are all going to be reading the Kubernetes API and watching for events, but this is a little easier. So when the KEDA HTTP operator, I got to put the ingress on the other side. No, because this is going to have to modify everything. I'm not going to muddy up the waters here. So let's make this a little bigger and we can describe what this does. Oh boy. Small, please. Oh God. You know what? Let's see what it looks like if I put arrows, because this operator has to touch the scaled object, the service, and the deployment, and the ingress. Yeah, because the activator is going to know about the app CRD, so we're going to have a lot of cross-cutting arrows here. The activator is going to have to know about the app CRD in order to... Can I do a curved arrow? Whatever. So yeah, the activator is going to have to know how to read the app CRD because it needs to be able to hold requests when there are no backend deployments before it sends them to the service. And the operator then rotate the top level. What top level? I feel like I did it before. I'll just leave it, it's fine. We can do this though. There we go. So the activator reads the app CRD. The operator then needs to modify the service. I want a real line for that. And it's going to need to modify the deployment and the scaled object and the ingress. And this is going to be a big old dotted line here. Jesus. Hey, Ivor Scott, what's up? I'm just getting used to Rust. This is my like first. I think I'm on week 3 of Rust. But I've been doing Go for quite a few years, so I can tell you. I can tell you my. What up, Nix? And KCA, what up? Good to see y'all. Yeah. So my impression of Rust versus Go so far. Morning, KCA. Yeah, Rust versus Go. All right, so Go, garbage collection, pretty unique concurrency because it's built into the core, not in the standard library. It's literally keywords in the language. Garbage collected. Those are probably the biggest 2 things. There's other stuff. It doesn't have generics. Doesn't have exceptions, things like that, but. The big 2 differences between Rust and Go are the concurrency primitives are baked into the language syntax. The way to start up a parallel and concurrent computation is a keyword in the language, not standard library stuff. And also there is a way to communicate between 2 different running, they're called Go routines, but they're basically user space lightweight threads. And the way to communicate with those is also built into the language proper, not the standard library, and used as a keyword. So that's a big difference from Rust. Rust has more traditional standard library based concurrency. It's based on threads, but then it also has futures and some other goodies built in on top of thread pools, which is nice. And then the big thing. I think a lot of us have heard about Rust's memory management system. So no garbage collection. Fairly, in my opinion, a fairly unique way to deal with memory called ownership and borrowing. So I'm getting okay at dealing with that. But for me, that's the real biggest thing between Rust and Go. So yeah, highest level as I can go. Put the operator on the right hand side. Can't do that, but I can do this. Move these up. Put you over here. Put you. So my good old dotted line, the long dotted line at least, doesn't mess too much stuff up. Whew, and then we'll make this dotted too. Why not? All the things. Make all the things dotted. Jeez. All right, this will have to do. Can I move this over to? That's a little better. All right. Yeah, I mean, it'd be cool. I wonder if I can figure out how to do curved lines. Edges. No, that's not helpful. Solid lines are not traffic, but that is a good idea. Yeah, okay. So yeah, let's have solid lines be network traffic. And then dotted lines be like, the dotted lines are basically going to be communication between background processes and Kubernetes resources. Stellar idea. Thank you, KCA. So operator is going to talk to the ingress. That is an operation via the Kubernetes API. Operator is going to talk to the deployment, which is another thing just as that. Same deal for scaled object. And this is going to be a multi-directional communication. We'll get to that in a second. Then the operator as well talks to the app, also multi-directional communication. Scaled object and KEDA communicate. KEDA communicates with the scaled object through the API. Also here. All right. Nitpick, the ingress doesn't talk through the service, goes directly to the pods. Ooh, good point. Okay. So I'm just representing the pods. I'm just saying deployment. So I hope that people People listening to this will, or not listening, reading this later will understand that. You know what though, KCA? I'm gonna represent this. This is not supposed to be. This is supposed to be the kind of high level architecture. So I'm actually gonna represent the ingress going to the service, since that, like, I want people to think of that sort of as a load balancer, even though it's not technically. And I also want the ingress to. I want to show the ingress sometimes going to this activator component, because sometimes the activator will hold the request until there are pods spun up behind this deployment, and it will forward to the quote service. Yeah. Oh yeah, and the activator is going to do multi-directional communication with the ingress. So I am actually going to delete the two-way thing and just represent dotted lines as communication with a Kubernetes resource. From a process to a Kubernetes resource. Whew, okay. I think this is everything. So we've got our HTTP ingress. Let me move this over here. I'm going to, not what I wanted. Not what I wanted. Okay, this. So I'm gonna move this up. This, in theory, like, this is the HTTP client is going to go to some cloud load balancer or something, but basically it's going to go through that infrastructure and hit the ingress controller inside of Kubernetes. Then, depending on what the ingress object says, the ingress controller is either going to go through the service to the pod directly or to the activator, and the activator will hold the thing. It will hold the incoming request while a pod gets spun up. The activator figures that out via, oh boy, all right, via, I'm just gonna leave that. It figures it out via the status of the deployment, but, oh, actually, we can do it like this. Not a big deal. It figures out when there's a pod available via looking at the deployment, the number of replicas, the actual replicas in the deployment. Once there is a pod, one or more pods running, then it will forward to the actual pod. The activator modifies the ingress when, let's see. Yeah, the activator modifies the ingress either when it needs to start receiving requests, intercepting requests, or it is done intercepting requests. So it watches the deployment to figure that out. It also needs to watch the app CRD because it needs to know when there is a new deployment up and that it should start watching. So activator is kind of not a great term. I'm not going to choose it. I don't have a great one right now, but I'm going to call it the interceptor. Yeah, so the interceptor is just a reverse proxy and a little process that it's kind of like an operator, reverse proxy and operator. It's a little process that modifies any given ingress as specified by the app CRD. All right, so that's the network path. Yeah, solid lines are traffic. Dotted lines are background communication with Kubernetes objects. Okay, so then there's the KEDA side. This is in the box down here, so I will put a little box here. Actually, we're just gonna put some text. So this is the KEDA world. This is what people should be familiar with. So that's just basically KEDA looks for scaled objects. Scaled objects tell it what deployment to scaled objects tell it what deployment to scale up and down. There is the matter of KEDA needing to figure out when to scale, and that we kind of specified as this thing called an external scalar. So the way that works was a little bit up in the air. But what I'm going to do for now is over here, put a little scalar metrics. So I'm just going to call it that for now. The implementation of this is going to depend on the ingress you choose. So scalar metrics is going to be off to the side. KEDA is going to communicate with it over background communication. And I'm going to put a little note here that this is going to be gRPC most likely, just because KEDA already has a gRPC scalar metrics protocol. Scalar metrics is going to communicate with something, probably, we don't really know yet. I think it's going to depend on the ingress, because the ingress might be Nginx or traffic. Those have Prometheus endpoints. We probably will have something like the interceptor, but all traffic will immediately go to that and not have an ingress, or still will have an ingress, but it will always go through the interceptor. Yeah, so scalar metrics, I'm basically gonna put a little thing here and then a question mark. Actually, not a question mark. We're gonna just put metrics source. And that's going to go here. We'll call it the HTTP request queue. Interceptor allows you to scale to 0 and catch the first N. Yeah, exactly. The first N, like, we're just going to call it the first N HTTP requests, just so they don't time out. Like, I don't want them. This is like a pattern also from Knative, but basically the idea is you don't want them just going to like a pod in creating state, because you don't know like what is that person's HTTP server doing behind the scenes. Is it running while the pod is creating, or is it a node app that for whatever reason needs to be like npm installing every time it gets started up? You have no idea. So yeah, the interceptor holds onto it in its own queue, and I think it depends on how we want to implement it. It might just have a queue with a timeout, or it might have a queue where it periodically polls the back end. Not really sure. Yeah, okay. So, and this scalar metrics is truly an RPC. I'm just going to leave it like that. Let's say gRPC here. Actually, to make this a little clearer, let's do this. Make you a little bit bigger, and make you go here. Whew! Okay, I think this about does it. I think I need to make it a little more complicated. No, I'm just kidding. Okay. Okay, I think we can maybe put this down here. It's a little clearer that way. All right, let's save this. Let's call this KEDA-HTTP arch diagram. Now, can I attach this? Will they let me upload images? Yeah. Did I not just save this? Oh, Excalidraw file. Let's not do that. But that's cool. Very cool. Export. Okay. Now what? PNG. Oh, cool. All right. Did I, again, did I not? Yeah, it's here. So, image files. Oh, it needs an extension. Thank you. Thank you, Ragabu. So you're gonna go here. Do it there. Okay, it uploaded it to somewhere. How do you work? That's interesting. I suppose I will put it in the ticket. As promised, here's the architecture diagram. It's a bit on the complex side because of all the communication between operators and Kubernetes resources. Happy to lay it all out. Next community meeting. GitHub, you don't have this anymore? Are you kidding me? Hello, GitHub? Oh God. Guess we're gonna put it in Imager, whatever. Oh, maybe, yeah, that's right here. Okay, duh. Arch diagram. And then let's see, Tom asked, what would it modify in Ingress? The only thing we need modified in the Ingress would be a way to get the link of the HTTP. Many of the ingresses I would assume have Prometheus metrics, so KEDA could possibly just talk to those. Yeah. And the arch diagram could be in a critical path. All right. Okay, all right. Apparently it did not update or upload the architecture diagram. Sweet. Okay, GitHub. Maybe it's me. Could not load, not a ping file. Yeah. We can try it as an SVG. Yeah, maybe. Well, you're right. I'll try it like this. Yeah, you got it. You're right. Okay. Now GitHub, now you are ready. Okay. I think this is good enough. There's gonna be a lot going on in this thing, and this will blow up. I think this will blow up a lot of questions. That's probably good. All right. I gotta go back here at some point and answer comments and questions that they have. But okay, sweet. Okay, I don't have to put anything on Imager now. That's cool. All right, let's build some more rusting. I have to save you. I have the Excalibur file. That's pretty good, but just in case. Okay. So hard coding the namespace for now, whatever, that's fine, blah, blah, blah. Where do we leave off here? We've got our reconcile function. Our reconcile function returns a reconciler action and an error. Oh, I remember this. The reconciler action, whether and when the next trigger of reconciliation, if no, yeah, so this is like a manual ping is the requeue after thing. So I want that to requeue. I'll always manual ping after 200 milliseconds if there's not an event that comes in beforehand. And we'll just do this to shut up the formatter. Error policy, same deal, except we're gonna wait a second after an error. So then after the reconciler runs, then you get a, yeah, so the results come out in this stream. Does run return a stream? Yeah, it returns a stream. It's a stream of results of object ref. And then the res, yeah, so then we match on it, we reconcile, and we're good to go. So we've got some crap here. Oh, you know what? We should, what does for each return? For each returns a future of something. What does it return? This won't calculate it for us. All right, fine. Why? What's the problem? What's the problem with you? Oh, is it because of, okay, so the future doesn't return, or the for each thing on the stream doesn't return a future of result or anything that implements try. So, okay, fine. So main's just gonna always return fine, okay. So I think we can build our thing, dead code, main.rs, line 57. Oh, right. Do we even use this? Oh, right, we do. Context. Where is context used? Oh, the run. And okay. So, right, run takes in a reconciler error policy and a context. The context then gets passed into the reconciler. All right, so that's cool. Our context has data. I guess the data is never, I guess Rust knows, the RLS or whatever it is knows that client's never accessed somewhere else. That's cool, okay. And that's all we have. So once we implement our reconcile action, then that will be fixed. Okay, so let's build a Docker file and let's see if we've got a pre-made one. Rust Docker file sample. All right, log rocket. Let's see what you got. Blah, 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 blah. Rust, does Rust have a Debian-based images? No, I see, okay. Cargo build dash release twice. That's interesting. Oh, maybe maybe I didn't scroll down. Yeah, that's true. Okay. Copy from builder, the app. Okay. All right, let's try this, and then we'll modify as we go. I don't mind running it in Debian. Hey, Stupak. Hey, thanks for stopping by. No worries. Hope your work stuff ends up okay. I hope, for all y'all, I hope the beginning of the week is going all right. Behind, you'll get caught up. No worries. Doing okay. This is my first and last stream of the week. I'm actually going on a holiday starting tomorrow. Holiday, as best as you can do a holiday without going anywhere in the world. But yeah, it's my first and last day of the week of work too. So I have some fun stuff planned for tomorrow. Cleaning the leaves out of the gutter. That's my big, that's my big activity. I took some, I broke down a wall yesterday on purpose. Some plaster wall, 100-year-old plaster wall. Yeah, homeownership pogger for sure. No. This is Rockeroo. This is my one day of work today. I'm actually working on work. Still fun, but technically, yeah, it's still work. But yeah, no streaming for fun because I'm gonna be doing Thanksgiving-ing. Maybe tomorrow, but very unlikely. But then Wednesday through Friday, I can't, unfortunately. I'm gonna be busy. Look at this later. All right, I got you. Just gonna bookmark it for later use. Oh, hell yeah. Stupak, nice. Those Japanese characters. Sold out. That's cool. It's a group buy. I'm sure there'll be another one. I assume there will be another one. I like dark mode. Obviously, I'm always a dark mode fan. I like it. I like it a lot. Engraved aluminum with Cerakote. I don't know what's that. Cerakote? Oh. And then you choose a kit. Yeah, I got you. It wants JavaScript on to remove the sold out. Yeah, no support for Lynx browser. Just kidding. And it's anodized finish, but different. Right on, okay. So what's with the, I guess, are those kanji characters? I guess is a good way to start learning Japanese. But this is sweet. Yeah, save for later. I got you. All right, let's try to build our thing. Build KEDA-HTTP controller. Come on, come on, come on. Damn, good internet speeds today. I have gigabit, symmetrical gigabit, but is it really? No. In practice, no. Come on. Yeah, absolutely, Rocker. All the time. And it's funny because I always look at the size of each layer. I'm like, oh yeah, the small one's gonna win. The small one never wins. Well, not never. Very infrequently wins, I should say. You got it. Request. Let's do it. I've heard this, that you have to like mount in the Rust compile cache. I'll get there, but I've heard that because, or the dependency cache maybe, because you gotta rebuild all the dependencies, blah blah blah. It's a pain in the ass, which I am seeing. I am seeing that now. Different here. It's fine. I just moved the comment. That's big change. Big change. Yeah, actually, when the router can handle 1 gig, I assume it's because, yeah, if I plug in at like 2 a.m. direct to the router, even with like my MacBook Air, it hits like 980 up and down. I assume it's just during the day. I assume. Making an elixir tree sitter grandma. I have no idea what that means, Rockerboo. I know what elixir is. What's a tree sitter? Is that like for the language server or something? Alright, so the Docker build failed because looks like that was the wrong name. Should be absolute. Okay. Oh, incremental parser for syntax. Nice. All right. I don't know why they're doing that. They shouldn't need to do that. I don't see why they would do that, at least. Cargo build -- release. Why do that? Why do that? Before you even have any Rust files. We're going to do that. So we're going to copy in. We'll do that. We can copy in the cargo.toml first. That's fine. And that layer will not change then most of the time. Copy in code. Well, actually, it doesn't matter. Copy in code. Then build for release. I assume that's gonna go into like a dist or target folder. Oh, hell yeah. This is what GitHub uses. Okay, nice. This is it? This is all you need? Some types. Is there something that like parses these into an AST or something? Hey, Andy Schneider, what's up? Good to see you. Happy Monday. Oh man, even outside of the containerized runtime, this is taking a while to build. Good old Kubernetes Open API. I challenge you to find a language where the Kubernetes Open API generated library is not massive, and if it's a compiled language, does not take up a ton of your compile time. Oh, you're making the tree grammar, so something else is going through and parsing that grammar. I guess. Dead code is on by default. Okay, that's fine. I don't mind that as a warning because I actually want that as a warning. Building. Come on now. Okay, you're done. So where did you go? There's got to be a target. There's no target directory? Yeah, there's supposed to be a target directory somewhere. Oh, damn. This is the tree sitters in JavaScript? I recognize this stuff. A module body, definition of a struct, blah, blah. Nice. So what's wrong with the one that's there already? You write the grammar in JS, it writes a bunch of C. Nice, okay. Compiled, makes sense. Oh, I actually gotta go, y'all. That's a meeting I gotta go to. Oh, bummer. Alright. We got somewhere. Let me check this in. Docker file. Alright. Good old GUI check-in. Let's find someone to raid real quick. I knew today would be busy. I just forgot about that meeting. Lol Mondays, that's right. Haven't raided CM Griffin G in a while. Let's raid him. All right, y'all. I will be back in 1 week. 1 week from now. Doing some more Go. Jennifer couldn't make it today, but she should be back on next Monday. So if you're in the US or you celebrate Thanksgiving anyway, hope you enjoy that holiday. Otherwise, for everybody, enjoy the rest of your week. Peace all.
Sort of guess like this is going to become the future of Facebook's native mobile apps.
All right, so
in 2015, I think he was looking.
Hey, what up, Marshals?
This could be big.
All right, let's just get back to the code.